Okay, in this video we're going to do the introduction to what's known as sampling. We're not going to cover everything, but we'll just have a look at some of the terms. So a sample is an unbiased representation drawn from a population. So if you want to find something out about a population, normally you take samples and check something in that sample and say that is a representation of the whole population. So a simple random sample of size n is one taken so that every sample of size n has an equal chance of being selected. Now, an interesting question here. The UK lottery involves selecting 6 numbers, one simple random sample, from the numbers 1 to 59. Find the probability of winning the jackpot. There are 59 numbers in the UK lottery, and a single sample of 6 numbers is chosen, i.e. sample size 6. The number of possible samples, is 59C6, or sometimes it's written like this, 59C6, and that's going to be 45,057,474. Only one of those samples is going to be the winning one. Therefore, the probability of winning the UK lottery jackpot is 1 over 45,057,474. Therefore, you can wonder why you never win. If we are choosing a number from a population, and the outcome is a number like in the lottery example above, then the members above will be written or will be labelled as X1, X2, X3, X4, X5, X6. These are the 6 numbers that we choose. If the population above is finite, i.e. 1 to 59, so this population is finite. Normally most populations are infinite. If there were n numbers in the sample, then obviously the last term would become xn. Okay, so these are just some of the things that we know about samples. Now, sample statistics. So what is the idea? Well, so when trying to find out information about a particular population, say I have the whole population of girls in a school, or the whole population of the school, and I want to find out the mean height, I'm not going to measure the height of every single person in the school. And what I'm going to do is take a sample and then calculate a statistic, and that statistic would be the mean height of my sample, and so that represents a population. So when trying to find some information about a particular population, random samples are taken and a statistic is calculated. Say we wanted to find the mean of an infinite population. Okay, to make this a little bit more simpler, let's say, to illustrate, we'll consider a simple finite example, like picking a number from a random samples from size 20 from numbers 1 to 48, and say what I wanted to know is what the population mean is. I know what it is, it's 24, but because normally we have an infinite population, but what I want to do is take random size of 20 and start calculating the means of those samples, and say that will represent what the actual population is. What I've got to do though is take random samples. Note, as the population is finite, we should replace. So when you've actually taken something, you should put it back in. So if I take 26, for example, I can put it back in. And we should replace to ensure that the selections are independent. Normally we wouldn't bother to do that, maybe if the population is infinite. So the mean of each sample is calculated, and this is called the sample mean, and we have this idea of x bar. And we say that this is a representation of the population mean, mu. Normally for a given population this would not be known, but in this population of 1 to 48 it's obviously known. Okay, and you would calculate x bar by doing x1, x2, hopefully up to x20, because there's 20 in the sample, and then divide by 20. Now we can actually do this experiment you can actually do it on an Excel spreadsheet. So if you go to an Excel spreadsheet, here's one that I've done already. Okay, so what I've got here is the sample x1, x2, x3 up to x20. So this is one sample here. Okay, what I did is I actually took 20 samples. Okay, and I calculated the mean. Okay, and you can see really they don't vary very much, apart from that one maybe, they do vary very much from 24. They're fairly close to 24. Alright, obviously the bigger the sample size, the better this would be. Okay, however, what I did notice, if I took the mean of the means, I did actually get what the actual population mean is, in this case 24. Remember, normally we don't know what the population mean is. Okay, so this is 20 random samples of size 20 from the numbers 1 to 48. So I'm going to show you how I did this so that you can try it for yourself. So I made a sample and I put the numbers at the top. I put these down here. Here I calculated the means, okay, and here I got the mean of the average of these. Okay, so going to a different tab. So here I've got a different tab. Okay, and I'm going to put the cursor there. Alright, you need to select data. So select data, and then you need to go to this one at the end here called data analysis. Now if you haven't got this, then you have to add it in as an add-in to begin with. Okay, so I've got this, and what I'm going to do is a random number generator. Okay, I want the number of variables I'm going to select is 20 because I want 20 in my sample. Okay, and the number of random numbers, the number of samples is going to be 20, so I'm going to put 20 across here. Okay, now you can take samples from a uniform, though it is a continuous uniform, normal, binomial, and Poisson. These are going to be two that we're going to be interested in later. Just go back to that, sorry. But at the moment, all I want to do is just do a normal, but we are going to be interested in doing binomial and Poisson much later. Okay, I'm going to select the numbers between 1 and 48, and I'm going to make my output range. If I click this button here, I can select my output range, and I've actually already done it, but I'll do it again. You see, just highlight the things out here, and you put this. Alright, and then all you do is press OK. Now, what it's done here, of course, because it's continuous, these are not discrete values, so in order to make them discrete, with them all still selected, right click and format the cells and go to number and then reduce the decimal places to 0 and press OK. Now there's just one other thing maybe you want to consider doing as well. Okay, if you copy the cells by doing Control or Command C, and then going to Edit and doing a Paste Special, okay, and just putting the values only, and press that, okay. Right, when you refresh the page, they will stay the same. Okay, so these means come out here. Okay, this time we didn't get 24 as the mean of the means, we've got 25. Okay. But you can see here how you can get Excel to generate random samples, so it's quite useful. So going back to the one that I did here earlier. Okay, we know the answer to this should be close to 24, which was in my example. There is a copy of the one that I've made. If you want to have a look for yourself, you can screenshot this for yourself and have a look at it for yourself. Okay, the statistic is calculated entirely from the samples. It does not involve any unknown parameter, i.e. we're not using the population mean here. So it has no, and it is a numerical property of the sample. And that's all we're going to be doing, looking at numerical values of the sample. For an infinite population, the population mean is generally unknown, as I've already told you. The sample mean x bar sigma xi over n, so I will be 1, 2, 3, 4 out of 20 in my example, and the sample variance will be sample variance, okay, is x minus x bar squared divided by n minus 1. Divided by n minus 1 comes out much later in the statistics course. Our statistics, these are calculated from the sample. Alright, this is supposed to be called an unbiased estimate of the variance based on the sample, okay, and this is the sample mean. But this one here, the variance here, it involves using the population mean, so it is not a statistic, okay, so you cannot use this, okay, because this is generally not known, okay. So this has been a video, just a brief introduction to what we mean by sampling. I hope you understood what we've done here, and I thank you very much for watching.